Hi everyone, it's Nono here and we're gonna get started in a second. Okay, hi everyone. Again, it's Nono here and I want to welcome you to one more live stream on machine intelligence for designers. As you know, probably, we also do things for the Getting Simple podcast here. We do things that have to do with creative coding and many other things like design automation, workflow automation, many other things. Before we get started, I'll remind you as always to like this video if you want to support the work that I'm doing here with the channel week by week, and subscribe if you want to get notified when I go live next or when I upload new tutorials or new podcasts. The community is at None of the Masas Discord. You can join the server. This is Discord is a platform. If you don't know what it is, it's similar to Slack. It's a platform where we have chat rooms or channels and we can discuss many different things. It's getting a bit more active over time. And you can do with this URL or the QR code that is up there. Last week, we took a look at a few different things: automation, some sentiment analysis, workflows. You can take a look at the topics on the timestamps of the video, nonodoma/live/66. And as always, I would thank you if you submit any questions. I love to hear from you, so you can do that at gettingsimple.com/ask. And I do prefer voice notes because that way we can play on the podcast and then we can answer them there or maybe even on the live stream. Really quickly, I'll go to one of the latest questions that we got from Sorab. So maybe we can, so I have it here. So we're gonna do a slide and answer that properly. And here we have the goals of the live stream. So I continue researching on models that might be useful for building a collaborative AI sketching platform and trying to learn a lot about generative adversarial networks. And that's actually what I want to talk about today. We have, let me see how much time we have today. So I have roughly an hour, a bit less, to do this live stream. So that's what we'll do. And clear topics, well, we have a bit of more clear topics than other times. And probably we want to do an intro for the series later. But before, as I said, I would want to say, well, I want to say hello to the people who are with us live. So Rob Bill, are you back from your vacation? And also Jose Luis Garcia del Castillo, who's live with us today. Thanks for joining and thanks for your likes. And yeah, I do have a question answer template that I'm gonna open now. And as always, let me know if you can hear me okay, if you can see me okay. That's super helpful if you do. There is one thing that I really want to do, which is creating, automatically exporting slides from all of the presentations that I've done over time with Keynote over the different live streams, just to be able to browse through the thumbnails of each slide instead of having to open all presentations. And I have, sometimes I forget to stop Dropbox sync when I'm live streaming, but surprisingly this computer keeps handling live streaming pretty well. Okay. So I'm trying to look for a template that we have in some of the Q&A videos that we've done during the live stream. Oh, here it is. I thought that I had done this, so let's just copy this. And this is something I could actually do offline, but I don't have time. I don't want to dedicate a lot more time to prepare these slides because it's a bit time consuming. All right, so this is a question by Sora Matre, and this is not Sora. So yeah, let me see. All right, so that's Sorab, and this is not his question. So all right. All right. And Rob said that Puerto Rico was great. Yeah, I look forward to visit one day. All right, so question by Sorab Matre. Okay, so let me see if I can play this. Right, so marker, Q&A. Ah, that would be good if there is silence for more than 5 to 10 seconds to play a chosen background track. Yeah, I mean, I guess like I could do something like that with hijack. Okay. Hi everyone, it's Nono here, and this is a quick Q&A video in reply to a question sent by Sorab Matre to the live stream via gettingsimple.com/ask, where you can also submit your questions for the podcast or the live stream. The question says, is it possible to input a sketch with multiple elements and train a network to resketch it as a single vector line drawing, like withOneline.com? WithOneline.com shows drawings that have been made probably with Adobe Illustrator or by hand, just with like a single trace, right? Like without lifting the pen from paper, let's say if you were using pencil and paper. In the case of the work that we're seeing on the live stream, we've seen networks that map, or are we going to see these networks today as well? So from images to sketches, from like different sketches to colored sketches, networks that simplify photos as sketches or simplify rough sketches as other sketches, and also networks that get like a line drawing and vectorize it. That means that from a raster scan of a line drawing, we go to a vectorized version of the same drawing. And we've seen this on the live stream, and this is a really cool feature that is being developed more and more, and probably within the next few years we're going to see in software applications like Adobe Illustrator or other tools that already vectorize but not in this form. My answer to this question is that with the networks that we have access to right now, or at least the ones that I've played with, the answer is no. Sadly, we can't do this yet, but this is only with neural networks. We do actually have the output information with vector drawings. That means that we have polylines or different segments. Actually, the network that we were using in past live streams is called virtual sketching and actually uses Bezier curves, which we have also seen on the live stream. There is an opportunity for us to manually or computationally simplify those lines to be a single line, but we'll have to code in the logic ourselves. There is no way in which that happens. It's a suggestive idea that we could maybe train one of the latest machine learning network architectures, or like these generative networks that do image-to-image translation, and embed single vector line drawing or single line drawing as one of the reference styles that we want to be able to map our drawings to. And this is something that I'm thinking also with my sketches, that we could map not only to single vector line drawing, but also from rough sketches to simplified sketches, from simplified sketches to hand sketches or watercolors. And this is a really suggestive idea that we might look at on the live stream. And if you're watching this and you have any references, drop them in the chat, on the comments, or maybe on the Discord server. Thanks a lot for watching. I hope you enjoyed this quick Q&A. Thanks, Sora, for your question. I would ask you now, if you enjoy these type of questions, like the video to support the work that I do here with the channel, and subscribe if you want to get notified when I upload new videos or when I go live next. Bye. Thank you. Thanks for watching, and see you next time. Okay, so that's for my outro. I hope that these Q&As are interesting, right? I think this could be recorded offline, but the purpose of doing this live is that, make the questions that people send to the live stream and the podcast part of this weekly ritual. Okay, so we're running out of time. Let me make a quick intro here in case that we also edit this. Okay, marker. Hi everyone, it's Ono here, and this is one more video of the Intelligence and Sketching playlist. Today in particular, we're going to take a look at generative image-to-image translation networks. These are networks that are capable to learn a mapping from different domains. Different domains might be photographic images, like realistic photos, and another domain might be hand sketch drawings or line drawings or vector drawings. What we try to do here is go from one domain to the other. One might be photos, as I said, and the other sketches, and you want to convert, for example, the photo of a house into the sketch of a house, or maybe do the reverse task. There are papers, publications that have been able to map from, for example, from different pictures of animals, or from the domain of cat photos to dogs, or from horses to zebras. And this is a task that is becoming more and more common, and actually has shown that it has a wide range of applications in the terms of like generating new images, transferring style, or like even super resolution, fixing images, or generating new art or new images based on others that are more simple or easier to access. All right, and maybe an outro quickly, an outro. I hope you enjoyed this video. You can go to the Intelligence and Sketching playlist if you want to see more videos on similar topics that go through how to use machine intelligence to manipulate hand sketches, drawings, and other sort of images. Thanks for watching, and I'll see you next time. All right, sorry for those outro videos and intro videos, but it's useful later if we do anything. As always, I'm reading the chat. So I see here that Rob Beal says the author of Virtual Sketching app maintains a large list of papers here. And of course, I'm going to take a look because all of the references that you give me are always super good. And this seems to be an amazing page. A collection of sketch-based application papers. Star. This is the author of Virtual Sketching. Feel free to create a PR or an issue. SketchGAN toward diverse. Yeah, so this is a lot better than what I prepared for today, I think. But this would probably require for me to take a deeper look into some of these resources. The one thing that this shows is, you see how overwhelming the world of machine learning can be, right? So we do have a bunch of papers that are scrolling behind me, and these are just papers that have to do with the sketches, and we could keep going forever, right? There's just way too many. So with this is what I want to say is like it's really hard for somebody to follow along, and this person, so Mark Howard MO, has probably done a huge work in like archiving papers, and you can see that every now and then he adds new papers. So let's take a quick look. About 100 papers linked from that repo. Yeah, this is crazy, and thanks for sharing. Lines to face photo. It is overwhelming, and if you feel the same way, you think this is overwhelming, go to episode which we mentioned last week as well, right? But go to episode 63 of the podcast, and on the video we have this. I mean, you can see it here, so you can see on the markers. Where are you? Did I delete it? Okay, no, it's here. So minute 14:26, knowledge anxiety. This is something I had never heard referenced before like this, and I think it's basically something that I'm feeling, and I was feeling, and I expressed in this podcast, but Andrew coined, or like at least mentioned that term, that is super relevant. Let me see if I can play a little bit.
To work with.
And there is also kind of the end bit of the book, right? The last chapter, the doubler and the virtual. Many computation. I did some. I always have the sense that I like and feel you're doubling
with anxiety or. Yeah, it's this question of kind of like knowledge anxiety or expertise anxiety. It's a really interesting question because I feel like it's been with sort of like people in modern times and designers in particular since the early 20th century, and I'll come back to that in a minute. But I think in our context in particular, one of the things that I think is a little bit interesting about working, when you're working in sort of technology and design, there's always a process of retooling. There's constantly this process of sort of like learning and applying those new tools into new contexts. And you do almost feel like you're kind of like a perpetual dilettante. But one of the things that I've been finding kind of interesting recently is that I'll take on kind of like a new subject, and then
Right. I don't know. I think it's relevant. I'm not sure if that's the part. And dabbler, it's me. Yeah, I think we're all dabblers in this world of like continuous publications and papers and things. So yeah, there are many papers like this, right? Like try to do applications that I think, for example, this is 2019, probably some sort of alteration or like they compare themselves to peaks and within this world, there have been a lot of other contributions like StyleGAN and StyleGAN 2 and other networks. This is good to see. This is a good diagram in which we can see how the process, and this is something that I'm trying to learn, and hopefully you want to learn about it with me as well. Let's make a like a marker here. Yeah, and thanks, Rob, for your comment. I am glad that you like that. Okay, so let me see here. All right, so we do have here. This is from. Let me give the due credit. So this is from lines to face photo generation from lines with conditional self-attention generative adversarial network. And I'm not sure how good this paper is or no. I haven't read it. I just like click from that list that Mark shared before. But what we can see here is the kind of typical architecture of a neural network. I don't know what in particular these MRU or DMRU units are doing. But what you can see on the top is a generator network. It basically encodes the line drawing or the input image that we have on the GAN as a 1D vector. So it basically encodes that into some sort of embeddings or encodings. And then it upsamples and decodes that into another image, right? So you're trying to learn how to do this process from an input domain, in this case line drawings, to an output domain, which is like a photorealistic image. And in this process, there is a loss that has to do like the adversarial loss that compares the weights or that embedding that the discriminator is actually getting from an output image of the GAN with the what needs to be on the middle, right? Like that encoding. What you try to do is these networks try to make the other improve, and there are multiple different losses that can play into this flow, right? So when you encode, I believe, if I'm not wrong, the loss or like what is compared is the what's in the middle here with what the discriminator actually generates here, right? Like I think that's what it is, but we need to look into more detail. And there are many, so each paper, each publication actually uses different losses and different nuances of this process, right? All right, so the thing that I had prepared for today, because we're not gonna have a lot of time, so I do have here a post that will go out or will go live in 2 hours, and this is just a write-up, like a really quick write-up that I did before with some of the things that I've been looking at. So we have here um, a set of networks. So we have peaks to peaks, CycleGAN, SU, and I'm going to actually copy this and put it on a slide to be able to talk through it better. All right, so this works better. Okay, so these networks at least are the ones that I am more familiar with, at least Pix-to-Pix CycleGAN and StyleGAN. Those are the ones that I've seen the most. And I'm researching and taking a look at others that are within the same sort of evolutionary line, I would say, of papers that try to build upon each other and trying to understand them, like printing the papers or like reading through the PDF and highlighting and trying to understand, maybe making write-ups on the blog and understanding what they're doing. Pix-to-Pix, if you compare it to other networks like StyleGAN or Informative Drawings or CAT, it's really simple, let's say. I know it's super hard to get to see that architecture with the optimizers and those lambda values and the activations and the size of the convolutions and many of these things is super hard to get there. But to understand that you're effectively doing a down sample and then an up sample, and then the discriminator is sort of trying to see whether the generated images are fake or not, right? But when you look at something like informative drawings, like learning to generate light drawings that convey geometry and semantics, there are other losses involved in this process. For example, we have the clip loss, which has semantics, so it tries to understand what's on the actual photograph that you're inputting. There is also depth maps that are predicted or simulated with another machine learning model to make sure, as another loss of appearance. And then there is another, or geometry, I think, and then there is another loss of appearance. And also they use the loss of, they use a data set with data samples to basically make the network generate drawings that look like given styles in those data sets, right? Unsupervised, in an unsupervised way. And this is informative drawings. In CycleGAN, what they did was a twist to Pix-to-Pix, because what they do is that instead of having a mapping from A to B, so you have to train it and then you have to retrain it from B to A if you want to try to go reverse the domain, right? For example, from sketch to photo or to photo to sketch, you'll have to train twice. In CycleGAN, there is something that is called trying to achieve cycle consistency. And what this means is that there are two generators and two discriminators, and the network continuously tries to check that it knows how to map images from input domain A, so from domain A to domain B, and from domain B to domain A, just in one single line of training. And this has proven super effective and is being used in many other networks as well. And personally, I don't know which of these are creating the contributions from scratch or which ones are the most original, because as I said, there are hundreds and thousands of references between these papers. And for example, I know that I think CAT references StyleGAN and also references CycleGAN and other papers, Unit as well. So, what's interesting from here, and I'll post the link, so the actual private link that you can access right now, right? So I think I can copy it from here. I'll put the blog post. Yeah, so I put it on the chat, and from here I'm just linking to the corresponding websites of each of these networks. So for example, if we take a look at Pix-to-Pix, this is something I think I've already shown it on the live stream, but I won't, I cannot show how happy I am just for this. I thank the team. I don't know who's responsible for this, but when I started receiving through Google Analytics visits from this domain, I quickly checked, and the problem or the issue was that they had added my publication on suggestive drawing in here on the page of Pix to Pix. So I'm really happy. I haven't talked to the team, but like I'm really happy to be part of this, right? To be here next to people like Memo Atken and Mario Klingemann. So that's really humbling, and I really like that. But yeah, so these are pages that they do when they release the paper. There is usually the paper, there is the code repo, there is this page, which is kind of the summary. There are usually summary videos of presentations that they've given. For example, here there is this one that is from 2 Minute Papers. It's a really famous YouTube channel that you should probably follow. And yeah, so and they share also demos from other people. So Pix to Pix, we saw it a while ago. So these are the images that they got to work. The network by default works with 256 sided images, right? Those are pixels. Last weekend or week, I was just trying to see, basically as a thought or like a hands-on experiment, I was trying to change the input output size to 64 pixels just to see whether that worked or not. I had to actually go and get hands-on, change a few of the pre-processing methods, and also change the generator code and the discriminator code. So for example, I removed these two layers and made the input size 64 by 64, and I also removed these two upsample layers. So this is on the generator code, and on the then you can get like an image of how the generator looks with those changes. And you see that the input and output are 64 by 64 and 3 channels, and how this looks when you generate an image without any training. And then the discriminator, also like just removing two layers that were actually downsampling from 256 to 32 by 32. So here we just need one to actually do that. So probably there we're already getting, right, we get the image here and we already get the 32 by 32 vector. So yeah, that was an experiment. Rob Beal says that maybe this is how he found me, through Felipe Sola. Did you find this through this blog in here, or through some other channel like Twitter or something? So yeah, this was just a thought experiment, right, on TensorFlow Pix to Pix, which is a tutorial adaptation of the Pix to Pix network on the TensorFlow tutorials. You just get a button here to run it with Colab with the default segmentation maps to buildings or facades dataset, which was really successful back in the time. And I was also taking a look at CycleGAN, right? So if we go here, you can go to the CycleGAN publication, and then you can see there is this double-sided arrow that means that there is like a cycle consistency between domains, and you can go not only from zebra to horses, but from horses to zebra without having to retrain the network, right? Or like summer to winter and winter to summer. But also you can do like a photograph to different styles. And there are presentations here. Again, 2 Minute Papers covers the paper, which I think it's crazy. Yeah, let's open this because I keep seeing more and more, and it seems to have become like the default for papers. They have, or he has 1.2 million subscribers, and yeah, this is super awesome. All right, and yeah, there are many experiments here. Again, Mario Klingemann and many others who've played with this model. And if we take a look at how the model works, they did this mapping from GTA, right, Grand Theft Auto, to like a real looking image, which is really cool. And yeah, that's really nice. And then there is a lot of experiments. And then this, which couldn't be more relevant than today. And okay, so the papers are there, so you can take a look. I think, let me just quickly open the one of CycleGAN, most likely. Okay, and yeah, so you're trying to generate from X to Y and then trying to get the discriminator of Y to detect, and then from Y to X and then the discriminator of X. So you have a generator G and a generator F, and that's kind of how that's the model architecture. You can see here. So from X you go to G, and then you look at the discriminator, and then from F you go to X hat, which is, it's like a cyclic cycle consistency loss, and that is the loss. There are two losses, one for each discriminator and one for each generator discriminator pair. And here they list the potential applications of this network. What I was surprised about, because I think I definitely want to try to train some of these models, because it doesn't require paired training or supervised training. We don't need to map drawing A to image B to train. We just can input a set of images, and then the generator and discriminator will make their way into training themselves, let's say. What was really informative or explanatory for me was looking at contrastive learning for unpaired image to image translation, which they call CAT, because this makes me understand, at least this diagram, it makes me understand a bit better what it means to do a self-supervised training in this case. And what it tries to do is that there is a loss that tries to map each patch, right? That there are some networks that are called patch GAN, for example, right? And what this network tries to do is find a mapping from a part of an image to a part of another in a different domain, and it starts learning when certain patches actually have common features, right? Like here they can see, or like the network can see, that there is a background, there's an ear, there is an eye, there is some stuff, and then it says all of these other patches don't really correlate to this one, right? And that I don't know, for me it was a bit more explanatory, because I understand what that means that way. And what's really awesome is that using some of the learnings from, I think it's from StyleGAN, that's StyleGAN 2, that's what they mean, that's what they mention. They are able to do single image translation, basically from one domain to another, but just with one image, I think. I'm not sure if that's the case, but basically it's like style transfer. And we have the paper here as well. So let's see. Paired image to image translation maps an image from input to output domain using an adversarial loss. In unpaired translation settings, corresponding examples from domains are not available. In such cases, cycle consistency has become the de facto method for enforcing correspondence, which learns an inverse mapping from the output domain back to the input and checks if the input can be reconstructed. You see here they mention alternative, unit, and munit, which are networks that I believe are made by NVIDIA, propose to learn a shared intermediate content lattice space. Recent works further enable multiple domains and multimodal synthesis and improve the quality of results. In all of the above examples, cycle consistency is used, often in multiple aspects, between A to image domains, image to latent, or latent to image. While effective, the underlying bijective assumption behind cycle consistency is sometimes too restrictive. Perfect reconstruction is difficult to achieve, especially when images from one domain have additional information to compare to the other domain. All right, so that is important, right? Because it means that they're saying that cycle consistency is not only that, no, it's not the only thing that matters. So here, this is really fun. Like, they tell you where, for example, they're trying to do cycle consistency between two images, image to latent or latent to image. So we could go and say, okay, let's copy this so we have a reference, and maybe let's just put it here. So what I'm going to do is go to the references and try to see what papers those are, because that's usually what you need to do to like research and continue with the parts of the publications that you want to learn more about. So two image domains. Okay, 37. Learning to discover cross-domain relations with generative adversarial networks in International Conference on Machine Learning. All right. 81. Unsupervised dual learning for image-to-image translation. Let's take a look at that one. Hi, Mohammed. How's it going? Thanks for popping by, and I'm glad that you could join us today as well. DualGAN, unsupervised dual learning for image-to-image translation. I have not seen this paper, I think, but yeah, DualGAN makes sense. It's like two networks. In some way, I would probably like to make some sort of script that just by giving it the archive or archive URL, it gives me the papers with the names organized by date, because I like to know which one came first and which one was built upon the other. So it would be probably crazy to build relationships like that with papers, and probably there's some tool that does it. All right, so what is this one doing? Yeah, so this is also a cycle consistency of images. All right, so let's see 89. Let's see which one is 89. Let's see what this one is. Also, okay, unpaired image to image translation. Okay, so this is actually CycleGAN, right? For image to latent, this is number 10. So let's see if I can just do this. No, I can't. StarGAN, Unified Generative Adversarial Network for Multi-Domain Image-to-Image Translation. Okay, we also have number 30. So this is image to latent. So 30. Multimodal and supervised image translation. All right, so here we see Unified Generative Adversarial for multi-domain image-to-image translation. Input, blonde hair. Interesting. So is there implementation for this. StarGAN v2 is available. Okay, so here we would need the background music. Okay, so we're looking at the network celeb AHQ source. Okay, so this is really nice. I'm not sure if they tell you how to. Okay, training. Phase train. Okay, and here's how the data set should be prepared. So your data set, train, domain 1, domain 2. And I guess you can train with multiple domains. That's what it means, right? Multi-domain, so it learns how to map from one to the other. TensorFlow 2.1, that's nice. All right, so this would be a really nice paper to try. Let's write it here. StarGAN v2 for TensorFlow. Multimodal unsupervised image translation. And we haven't looked at these other ones, right? 41 and 44. Diverse image to image via disentangled representation and unsupervised image to image translation networks. August 2018. Okay, so this is also really interesting. This is, you see, this is what I meant before, that these networks over time are becoming more and more complex, and you know, we don't only have an image and we downsample and then upsample. We now have array parameters, which sounds to me something like a StyleGAN, and we have a content encoder and a style decoder. So we're trying to learn from its style and from its content. And what is this MLP? Our autoencoder architecture, the content encoder, consists of several strided convolutional layers followed by residual blocks. The style encoder contains several strided convolutional layers followed by a global average pool. The decoder uses an MLP to produce a set of array parameters from the style code. The content code is then processed by residual blocks with array layers. Okay, so let me take a look at this. So let me make a screenshot, put it on the slides of today. Okay. These were not the slides from today. I guess I can put this here and we can leave this as it was. Okay, so what do we have now? So we have this, and I might want to make a reference to the paper so we don't lose it. Maybe this is better. NVIDIA. So these, let's take a look at what ADAIM parameters are. I know that today's live stream is being a bit, a bit dense, but this is what I'm looking at. So I'm trying to understand, because I was trying to understand the virtual sketching paper, and I saw that, I was looking at one of the sketch simplification videos from Simosera, and I realized that, we need a bit more base for to be able to explain all of these things. Adaptive instance normalization, multi-layer perceptron. Oh, okay. So this is actually MUnit. It's something that I had seen. Okay, so let's try to finish, because I do have to go relatively soon today. So 90 is in here. So this is toward multimodal image-to-image translation, PATAC, and wait. So this is okay. So this is the same theme of CycleGAN. So this is CycleGAN, bicycle GAN. Okay, so let's add that to our list. So let's do bicycle GAN, and maybe, yeah, we put here the link, but we're also gonna put the GitHub paper. Now I understand why this is called bicycle GAN. Bicycle cycle GAN. All right. Given the same night image, our model is able to synthesize possible the images with different types of lighting, sky and clouds. The training requires per data. Oh, okay. So this does require per data. No, great. But I mean, it's awesome. Okay, so they're citing. Okay, cool. So that's bicycle GAN, image to latent, and let's see latent to image. Let's see what the difference is, and maybe maybe we could have made a list. Maybe a bit too late. So 90 is 90, that one? Yeah, so this is bicycle GAN or bicycle GAN. This is this one. Let's see, 44. While I'm looking at this, do you guys have any questions or any comments? And supervised image to image. Background music sounding while I'm not. This video is a good way to see how certain of these papers compose. Can't really click on that video. Let me see if I can copy Zhang's dissertation talk. Yeah, that's what I'm trying to actually see. And this is great, Rob. Oh, this is awesome. Yeah, so this is something I also have to watch. Right, so we'll add it to none of my watched, or it's not watched, right? But why? Okay. not watched. It's things I want to watch. So okay, so this is the author. So yeah, you can see the things that I've been looking at. Edgar Simo Serra, Philip Isola's talks, and many of these things recommended by you, Rob. And yeah, this is great. He actually talks about all of them, right? Like colorization, the color by CycleGAN, perceptual. Yeah, it's nice. Yeah, this is an awesome video. Okay, I have to watch this. And all right, so let's continue. Okay, I assume I don't have time for this today, so I'm just gonna put this on the slides in case we will come back to this in the future. And I'll post these in here. Okay, and things I wanted to show before I go. So it's been short. I don't know for you, but it's been short for me. I'm gonna leave this open, add in parameters. I think this is also what StyleGAN 2 uses, right? Adaptive instant normalization is redesigned and replaced with a normalization technique called weight modulation. All right, so StyleGAN, what we have, StyleGAN 3. The one I've been using is StyleGAN 2. All right, so the one thing that I wanted to show, I have a few links here, just really quickly before we go. We have, so Apple's S plus U, so simulated and supervised, we couldn't go through it. We do have informative drawings which so DBS shared last week on the Discord community, and I was super surprised to see what this can do. So let's actually get a photo. Let me see if I can find a photo of from my phone. Let's actually just get any photo. So if I do get a photo of myself, for instance, let's just get this one. Let's see what happens if I put it here. So style 1, right? So it tries to sketch it out in some way, and then this one. So this is Hugging Face or using Gradio or G Radio. And what it tries to show is that you can convert, this is a GAN, so it converts from this domain to this one with informative drawings. And we haven't taken a look at informative drawings here. I think I did last week, but I haven't. Let me see. So on the post, I actually linked to informative drawings, the publication, and you can see this diagram. Actually, I do have a write-up on the blog, so none of them ma. And you have this one here. I wrote Philip Isola did again, learning to generate drawings that convey geometry and semantics. But, looking at the work of all these people, I see that code is always written by other two people who I guess, that he's advising. So it's not just Philip Isola, there's a lot of other people involved. But, he's the kind of the common denominator in Pix to Pix and some of these things. I don't think he was in CycleGAN though. And this was an image that I did, which, we could also use this for sketch simplification. This is awesome results. And the network architecture, right? What I was mentioning, that we have different losses, like a loss with unsupervised data. And also we have three losses: clip for semantics, an appearance loss, which is from the generator, I guess, and then the geometry loss, which comes from trying to infer the depth maps from the input image. And that's for informative drawings, which we're not gonna see anything else more from today. But I do wanna go, and we also have a unit, but I found Imaginaire, I guess, because it's like a French word. This is a PyTorch library that contains optimized implementations of several image and video synthesis methods developed at NVIDIA. So this is actually crazy because it contains, let's take a big look at this. So it contains Pix2Pix HD, SPADE, Unit, MUnit, FUnit, Coco Unit, Bit2Bit, FS Bit2Bit, WC Bit2Bit, GANcraft, and those are many networks that are awesome. You can go to each of these inside of Imaginaire, and then you can see how to train it. And I guess this is for projects, but I'm not sure where the code is, right? So let's see, generators, Pix2Pix HD. And here you have the code for the generator and probably other parts of the network. And yeah, I don't know, you have a lot of code here, which is crazy. I'm not sure where to start reviewing things, but yeah, so that's for Imaginaire. And then we have two other things I want to show. Oh no, three things. One is DALL-E, well, DALL-E and Clip, right? So DALL-E, so let's go to Clip quickly first. Clip tries to connect the text domain with images and tries to, be able to describe what's on a picture, or like generate, or like, yeah, I don't know, like there is graph here, right? So going from, it does contrastive learning with the text encoder and an image encoder from different types of data, and it tries to then describe images. That's what it tries to go from the image domain to the text domain. And what they did with this is try to go and then make a generator, which from the text domain, so for example, like an illustration of a baby daikon radish in a tutu walking a dog, right? And generates these images, which I personally believe it's a bit crazy. Baby fox, baby manatee. I don't know. I think this is a bit crazy that this works. Yeah, I don't know. I mean, take a look at these things. This is DALL-E. Put it on the chat. I'm gonna put Clip on the chat as well. And the latest thing, you see, I'm speeding up. The next thing is Microscope, which I'll also put on the chat. Is as this says, it's a collection of visualizations of every significant layer of the neurons of 13 important vision models. So if you go, for instance, to, I think Inception was, well, I mean, ResNet is a bit too crazy. Inception 4. There is one that I saw that was really nice because you could see dataset samples. Yeah, right. So from each type of data, it gives you the things that is learning to generate or like to differentiate. I don't know. This is a bit crazy that they made this. But this is all the information that is on a neural network. Yeah, Microscope is great. I discovered it this last week, and it not only lets you see those but understand what each part of the network is doing. And I think it's great because it gives you a sense of what's going on inside of the network and why. So this one is trippy. So if to understand this, right, if an input image is able to fire, right, to activate these networks because it's generating information that is really similar to it, then the network will classify the pixels that are matching to whatever class that neuron belongs to. That's basically image classification, I think. Let's see if there are eyes here. It's the optimized image that maximizes activations. Let's randomly tweet this. All right, and I think this is it. I think I don't have any more links. This is what Sorab was referring to. This is the with one line. These are one single line sketches. And that's it. This is from my end. Oh, I had this one that I particularly liked. I don't know where layer that was coming from, but it was from like images of demonstrations, like people actually shouting on the streets. And I think this is a bit crazy how well represented this is, how well this works. All right, so this is it for one more one more Thursday. I would ask you again to like this video if you're enjoying the content and you want to support the channel. And remember to subscribe if you're not subscribed yet, if you want to get notified when I go live next or when I upload new videos. I'll see you on Discord during the week. Until next Thursday, thanks a lot for watching, and I'll see you next time. And for you guys who are online, Rob, Jose Luis, and others, Mohammed, thanks a lot for your time, for your attention, and your love. Yes, thanks, Rob. And yeah, let's see. Maybe we can catch up also at some point. Bye bye. Thank you for watching. Bye.